Avoiding common failures when specifying wall and floor tiling.
Norcros Adhesives is part of the Norcros Group, and alongside sister company Johnson Tiles, it is based at the heart of the UK ceramics industry in Stoke-on-Trent. The company is a leading British manufacturer. The product range includes branded adhesives, grouts and surface preparation products for fixing ceramic and porcelain tiles, mosaics, natural stone and marble. Quality is vital to Norcros adhesives, so only the finest raw materials are used, along with increasing proportions of recycled materials. Strict quality control checks are performed on all incoming materials upon delivery. The modern, fully automated manufacturing and packaging plant employs lean manufacturing techniques for the high-volume production of polymer-modified powder adhesives, grouts and screeds, together with professional performance ready-mixed adhesives. Once the products are manufactured, the extensive care doesn't stop there. Each batch is individually tested, and high-tech machinery seals and palletizes each bag. Investment in state-of-the-art machinery at all stages of the production and packaging process enables Norcros Adhesives to manufacture, package and distribute technically advanced products within very precise manufacturing parameters, and with a minimum of wastage and environmental impact. Norcros Adhesives takes its environmental responsibilities seriously and is ISO 14001 accredited for reducing waste and improving resource efficiency. Norcros Adhesives continually refines and develops its product range, improving existing products and adding innovative new ones. The company's future growth comes through continued innovation and rigorous R&D to create the next generation of adhesives. This is the way Norcros Adhesives keeps one step ahead of its competitors. The company's recent investment in a new skills centre allows for the delivery of a wide range of practical courses for tilers and retailers, giving real insight into product development and installation techniques. In this way, investment by Norcros Adhesives is benefiting the industry as a whole. The Skills Centre enables Norcros Adhesives to deliver REBA-accredited CPD courses, which are a welcome resource for architects, helping to drive up product knowledge and technical expertise within the industry. As well as theoretical training, students also get the chance to try out practical skills that they have learned. Exceptional training support is at the heart of the Norcros Job Done ethos. The Technical Helpline is a one-stop resource for advice and support on products, system installation and more. Site visits, technical reports and remedial advice are always available. All Norcros products come with a lifetime guarantee. It's the company's promise to the industry. It all adds up to a success story in manufacturing, sales and distribution for Norcros Adhesives. It is the one-stop shop for high-quality, British-made products.
By the end of the seminar, when faced with common tiling backgrounds and bases, the learner should be able to identify the watch points which can lead to common tiling failures and know how to avoid them. Through understanding the importance of the correct identification and preparation of background and bases, the correct product selection of tile types and specification of fixing materials such as adhesives and grouts, the correct installation practices in accordance with British and European standards and surrounding legislation. Considerations when specifying tiling for floors: tiling over wood-based substrates, tiling over screeds, best practice floor tiling installation. Considerations when specifying tiling for walls: tiling over plasterboard, tiling over tile backing boards. Tiling to floors. It is vitally important to check the flatness of the background or subfloor before tiling begins to ensure that the tile can be solidly bedded. Backgrounds should comply with the requirements of British Standard BS 5385, which states that, when checked using a 2-metre straight edge, any gap under the straight edge between points of contact does not exceed 3 mm. Local corrections of the background may be necessary where the gap exceeds 3 mm. Subfloors should be laid to surface regularity SR1. If the surface is inadequate, it should be corrected before tiling begins. The surface flatness of the finished tiling should be such that, when checked with a 2 meter straight edge with 3 mm thick feet at each end, the straight edge should not be obstructed by the tiles and no gap should be greater than 6 mm. Surface regularity and a robust aesthetic tiled finish requires not only good installation techniques and product selection, but also the correct treatment of bases to be tiled onto. Tiling over wood-based boards. Considerations when using wood-based boards. 1. Thermal expansion and contraction. 2. Deflection and how to test for it. 3. Associated tile failures. 4. Common problematic board types and how to avoid tile failures. Wood is very reactive to temperature and expands and contracts at a different rate to the sort of materials that are used within tiling installations, such as cement-based adhesives, ceramic, porcelain, and natural stone tiles. It expands across the grain further than along the grain. Associated problems with thermal expansion. The photograph illustrates adhesive cracking caused by movement in a timber floor. The photograph shows grout cracking caused by movement in a timber floor. The cracking caused by movement in a timber floor is clearly shown in the image. Deflection in this case is defined as the movement or curvature created in a timber board or sheet when it is subjected to loading. Heavy loads can cause deflection, leading to buckling of tiles and cracked tile installation. Therefore, it must be ensured that the floor will be able to support the expected weight of the tiling materials with minimum deflection. The level of deflection can depend on the weight of the tiles and the rigidity of the existing timber floor. In order to test the surface for deflection, use the meniscus test method. Simply put a glass tumbler filled with water onto the floor and stand approximately 1 meter away. Jump up and down. If the water is spilt, then the deflection is too high. Deflection of loads can cause tile failures, as shown. 2 common types of problematic timber floors include plywood and chipboard. When tiling to plywood floors, always ensure that the plywood is a high-quality Class 3 external grade WBP or marine grade plywood as recommended in BS 5385 Part 3. There has been an influx of cheap low-grade plywood which is often impregnated with an oil which inhibits adhesion and prevents the adhesive from bonding, resulting in delamination at the plywood to adhesive interface. As mentioned earlier in the seminar, the meniscus test can be carried out to assess whether an overlay is required. If the meniscus test indicates that the deflection in the floor is minimal, then a rubber crumb S1 or S2 adhesive may be used. If the meniscus test indicates that the deflection in the floor is excessive, then to minimize deflection movement stresses, BS 5385 Part 3 recommends overlaying the timber boards with plywood. Some existing floors may require strengthening, for example with an overlay of Class 3 exterior grade WBP plywood to BSEN 313 Part 2 or marine grade plywood to BS 1088. BS 5385 Part 3 recommends the required rigidity might be achieved by fixing WBP exterior grade plywood of 15 mm minimum thickness over existing boards and screwed to joists in existing boards at 300 mm intervals. In this situation, an anti-fracture membrane can be used as an alternative to a board overlay, as the mat will allow movement of the board whilst reducing height differences between different floors within the building. Innovative anti-fracture membranes are as thin as 2 mm and provide real advantage against traditional membrane thicknesses regarding the floor build height and transitions from room to room. Due to the nature of plywood, if it comes into contact with moisture, then it may become distorted, which in turn causes tiles to crack and debond. The solution to this is to ensure the ingress of moisture into plywood does not occur. Sealing with a neat styrene butadiene rubber primer on the back, face and edges of the board is essential to prevent the subsequent distortion of the boards due to atmospheric humidity. The same problem with deflection and expansion due to atmospheric changes occurs when tiling to chipboard as with plywood. Waxed chipboard should not be tiled directly onto. A plywood overlay or tile backerboard should be applied and mechanically fixed to the chipboard at 300 mm centers. Using plywood or appropriate backerboard will also strengthen the floor sufficiently to use polymer modified adhesive over the top. The minimum thickness for a tile backerboard is generally 10 mm, and plywood overlay must be Class 3 exterior grade WBP or marine grade plywood, a minimum of 15 to 18 mm thick. Unwanted chipboard may be tiled directly onto, dependent on its rigidity and the deflection caused by the load. To tile directly to chipboard, it must be deflection free. If this is not the case, then BS 5385 Part 3 must be referred to, as discussed previously in this slide. Refurbishment of press office cafeteria. The challenge was to provide fixing systems that would enable tiles to be fixed to 3 different substrates, including concrete, existing floor tiles, and woodblock flooring. A rapid setting grey adhesive suitable for fixing porcelain was used on the solid concrete floors and also on top of the existing floor tiles. A slurry bonding coat consisting of 2 parts adhesive mixed with 1 part SBR primer was brush applied onto the tiles to provide a key before installation. By using a 2-part rapid setting elastometric adhesive suitable for tiling to wood surfaces, it was possible to fix tiles securely over the woodblock flooring after the floor had been prepared. An epoxy grout was then used in all areas to ensure a hygienic, easy clean surface. Tiling onto screeds. These are the considerations. 1. Moisture content and recommended drying times. 2. Expansion and contraction, shrinkage. 3. Common problematic screed types and characteristics to consider. When laying cement sand screeds, initially the water must be retained within the screed whilst it gains strength, but after a period of around 7 days, the polythene sheet stopping the water evaporation will be removed and the screed should be allowed to dry for a minimum of an additional 14 days. BS 5385 Part 3 specifies that a screed should be left for a minimum of 3 weeks to dry prior to tiling. This differs from the recommendations in BS 8204, which recommends an allowance of 1 day per millimetre for thicknesses up to 50 mm. Thicker substrates may require 2 days per millimetre. The time taken for anhydrite screeds to dry is generally around 1 day per millimetre up to a thickness of 40 mm, with an additional 2 days per millimetre above 40 mm. However, this will vary between brands, so it is best to seek the advice of the manufacturer. It should be noted that the removal of latents will help to dry the screed. The main problems that occur when tiling to cement sand screeds arise from the drying out process. As the water content evaporates from the screed, it shrinks. This can cause problems as tiles may tense if the screed is tiled onto before it is completely dry. Common problematic screeds for tiling onto are cement sand screeds and anhydrite screeds, both for different reasons. Firstly, let's take a look at cement sand screeds. Cement sand screeds generally consist of 1 to 3 or 1 to 4 parts cement and sand mix, and are usually laid at a thickness of around 50 mm. A cement sand screed can either be applied to a concrete base or a damp-proof membrane. The screed is referred to as being green from initial application through to the point at which it becomes fully stable. The best solution for tiling to green screeds is to use a suitable anti-fracture membrane to allow lateral movement between the screed and adhesive layer to avoid the debonding of tiles, as the screed may shrink further and move as it settles. This method can reduce the recommended drying time from 3 weeks to as little as 48 hours. Adhesive products were used during refurbishments for the installation of the workshop floor. Working to strict time constraints, whilst providing solutions for issues such as problematic substrates due to solvent ingress in the screed, a full program of works was required to keep the workshop functional. This was achieved by using the following products: an anti-fracture membrane, a rapid setting adhesive suitable for use with porcelain tiles, an SBR primer, a flexible floor and wall tile grout. Anhydrite screeds offer a number of advantages over cement sand screeds, including large areas can be laid in a short time. Up to 2,000 meters squared can be laid in a single day compared to 100 to 150 meters squared when using conventional sand cement screeds. They are low cost. In 2017, a ground floor installation using an anhydrite screed costs an average of £2. This is £5 cheaper than a sand cement screed. They are pumpable and self-leveling, making them quick and easy to lay. There is minimal shrinkage during the drying process. They are suitable for use with under-tile heating as long as the elements are covered by at least 25 mm of screed. They are high strength, achieving a compressive strength of between C20 to C35. They are eco-friendly, having a low manufacturing carbon footprint and also being recyclable. The major problem associated with anhydrite screeds is the increased drying times compared to sand cement screeds, as discussed in an earlier slide. Another disadvantage of anhydrite screeds is the weak layer of latents which is formed on the surface. This needs to be removed by sanding or grinding before tiling can commence. The removal of the latents will also aid the drying process. Another disadvantage is that when a cementitious adhesive is applied directly to the screed, it reacts with the gypsum and produces a mineral called ettringite, which is formed at the adhesive and screed interface and is liable to cause the adhesive to debond from the screed. To avoid system failure, the problems which can occur when using an anhydrite screed should be taken into account, and the following actions should be carried out. When preparing the screed, the latents must be removed 2 to 6 days after it has been laid, although this is dependent on the brand of screed used and should be advised by the manufacturer. Ensure the floor is completely dry. The residual moisture should be less than 0.5%. Again, the total drying time of the screed will depend on the brand used. Before commencing, ensure that the surface of the floor is thoroughly clean and debris-free, as with any other application. It should be noted that anhydrite screeds are gaining in popularity. There has been an approximate 40% increase in the volume of anhydrite screeds installed between 2008 and 2016, whereas sand cement screeds have only just returned to the volumes achieved in 2008. Due to the gypsum content of the screed as mentioned previously, there are 2 solutions to prevent the formation of ettringite at the adhesive and screed interface. Solution 1. Using a cement-based adhesive with an SBR primer. The screed must have achieved a relative humidity of greater than 75%, generally at least 80 days for a 60 mm thick screed. The first solution is used when it is intended to fix the tiles in a cement-based adhesive. To avoid the formation of ettringite, the screed must be sealed with an SBR primer. The first application should be diluted to 1 to 4 parts SBR to water and should be allowed to dry before applying a second coat of SBR diluted to 1 to 3 parts SBR to water, applied at right angles to the first. Once both coats are dry, check that the screed is completely sealed by dropping water onto it. If the water sits on the surface in a bubble, then it is assumed that the screed is sealed. However, if it is absorbed, then add a final coat mixed at 1 to 2 parts SBR to water and allow to dry. Solution 2. Using a gypsum-based adhesive. An easier solution for tiling to an anhydrite screed is using a gypsum-based adhesive. The screed must have achieved a relative humidity of not greater than 85%, slightly reducing the time required for drying. Some manufacturers will supply such adhesives that reach the strengths of a C2 cement-based adhesive. BS 5385 states that, if using a gypsum adhesive, only remove loose debris from the surface. There is no need to sand the screed, therefore saving time during installation. In order to ensure the surface is dustproof, prime with a 1 to 4 parts SBR to water mix to suppress any dust that may be on the surface. Fast track method. A 3-part preparation system is now available which enables an anhydrite screed to be leveled or tiled using a cement-based adhesive after a minimum of 7 days or a maximum 95% relative humidity. This means that the drying time for a 40 mm screed is reduced by at least 32 days and a 60 mm thick screed by at least 72 days, providing cost savings on the build. On the bank of the River Thames by the Tower of London, Sugar Quays is a prestigious new development by a major house builder. Working closely with a leading manufacturer of anhydrite screeds, full on-site trials were performed on a new fast-track solution to tiling to anhydrite screeds. The system offered major cost savings to the builder, enabling tiling to be performed just 7 days after the screed had been laid. It also allowed floors to be tiled before the underfloor heating system was commissioned, without any detrimental effect on the finished surface. This is a major positive, as commissioning of underfloor heating can add delays of anything from 14 to 28 days before tiling can commence, and obviously cannot be performed until the services and the boiler are connected. It also managed to bring the project back on timescale, alleviating penalty clauses in the contract. The trials were monitored and assessed by the house builder and an independent body and were successful, resulting in the system being used on site. Flaws, installation techniques. The key to a successful project using large format tiles is preparation of the background and solid bed fixing. Preparation of the background is vital because final adjustment of tiles is very difficult. BS 5385 states in Part 3 that the notch troweling and buttering method combined should be used for fixing large format tiles and tiles with ribbed, deep-keyed or heavy buttoned back profiles. A thin coating of adhesive buttered over the backs should fill the deep keys before placing the tiles in position on the combed adhesive bed. There should be no significant increase in the bed thickness. Where a pourable adhesive specifically designed for bedding large format tiles is used, the adhesive should be mixed and applied in accordance with the adhesive manufacturer's instructions to ensure that solid bedding is achieved. Selection of a suitable adhesive is also paramount, and as stated in TTA document Large Format Tiles in Internal Tiling, when fixing tiles to floors, a cement-based tile adhesive meeting the requirements of Category C2 conforming to BSEN 12004 should be used. A Class C1 adhesive may be suitable providing that the tile does not have very low water absorption characteristics, Class B1B or A1B and higher, and the floor is of solid construction. For fixing larger format tiles which have a greater surface area to cover with adhesive, bearing in mind the importance of achieving solid bed fixing on floors, use of a pourable lower viscosity adhesive would be advantageous. Tiling to walls. Plaster is one of the most common wall backgrounds. However, there are some factors which must be taken into consideration when applying tiles. Background preparation is imperative to the success of tile installations, and therefore the following steps should be taken to ensure a suitable background. Firstly, it must be ensured that the plaster surface is a finishing plaster rather than the backing coat. The finishing plaster can be identified by its smooth and often shiny finish. Backing plaster is of a much coarser texture and can crumble easily, making it unsuitable to tile directly onto. The gypsum content of plaster can also provide a problem, as mentioned previously in this seminar, and must be taken into consideration when choosing a suitable adhesive. Once you are sure that the surface is finishing plaster and therefore suitable for tiling, you must dry brush the surface to ensure the surface isn't too smooth. This is so that the tile adhesive has a key and to ensure that any weak, fine material is removed. Gypsum-based plaster requires special consideration. Ettringite crystals are formed due to a chemical reaction between cement and gypsum-based materials. To avoid this, use an SBR primer and C2 adhesive, or alternatively, a suitable ready-mixed acrylic or gypsum-based adhesive. If using an SBR primer solution to suppress dust and/or reduce the porosity of the plaster, paint on 1 part primer to 4 parts water, covering the whole surface area to be tiled. Allow to dry before tiling commences. Plaster must be dry before commencement of tiling. In good drying conditions, a plaster skim coat to an existing backing coat or board must be at least 7 days old. A new backing and skim coat must be allowed to dry for at least 4 weeks. Weight of the tiles and adhesive should also be taken into consideration when tiling to walls, and due to the lower weight capacity of plaster in comparison to some stronger backgrounds, this should be checked, particularly if large format tiling is being considered. Plaster is sensitive to moisture, and it should be avoided in wet areas. However, if it is present and subject to wetting, then a suitable tanking system should be used. Tiling to plasterboard. The use of sheets and boards that are subject to movement from changes in moisture content should be avoided if at all possible. If such boards have to be used, they should be restricted to small areas and installed in such a way that they provide a dimensionally stable and rigid background. It is essential that all board edges are fully supported. As with gypsum plaster backgrounds, it must be ensured that the gypsum content of the plasterboard does not react with cementitious adhesives by priming with undiluted SBR primer. Plasterboard, like plaster, is also sensitive to moisture, and it should be avoided in wet areas. However, if it is present and subject to wetting, then a suitable tanking system should be used. Plasterboard can support a considerably heavier weight than plaster. Before tiling, it is essential to ensure that the board selected for tiling is dimensionally stable for the environment, so that it will not become distorted during or after the tiling installation or due to changes in moisture conditions. In the 2018 revision of British Standard BS 5385 Part 1, plywood is no longer recognised as being a suitable background for direct wall tiling and should be replaced with a bespoke tile backing board. Tile backing boards provide a rigid, dimensionally stable substrate to moisture and thermal movement, which is suitable to receive a direct tiled finish, and are available in a number of materials, such as foam core, fibre cement, and other materials such as magnesium oxide. The board type should be selected to suit the relevant conditions. Boards manufactured from magnesium oxide are considered more environmentally friendly than cement or gypsum-based boards, as they produce very little in the way of carbon dioxide emissions during the manufacturing process. Some boards are waterproof and only require joints to be taped with a waterproof tape. However, the relevant manufacturer's recommendations must always be followed regarding waterproofing requirements. The board selection should take into consideration the overall weight of the tile and adhesive that they must support. The waterproofing requirements and the substrate assembly, for example timber or metal stud-work, existing block or brick, plywood or plasterboard, as this will dictate how the backing boards are fixed. Boards can be mechanically fixed with screws and washers or laid into an adhesive bed. However, it is essential that the board manufacturer's recommendations are followed. Board thicknesses can start from as little as 4 mm, and it is essential that the correct thickness of board is used to suit site requirements. As with any background, it is essential that the boards are adequately braced to provide a rigid surface, free from any springiness and surface undulations. It is also essential that there is no distortion of the boards during or after completion of tiling. As stated in the previous slide, some tile backing boards are waterproof and only require joints to be taped with a waterproof tape. However, the relevant manufacturer's recommendations must always be followed regarding waterproofing requirements. The weight capacity of the board is dependent upon the type of board being used and can range from around 40 kg per metre squared to 85 kg per metre squared or above. Always check with the board manufacturer that the board selected is capable of bearing the anticipated load, ensuring that allowance is made for the weight of the tile adhesive. You should now have achieved a thorough understanding of how to specify for tiling when faced with common backgrounds and bases. You should be able to identify the watch points which can lead to common tiling failures and know how to avoid them. You should also have a thorough understanding of the importance of the correct identification and preparation of background and bases, the correct product selection of tile types and specification of fixing materials such as adhesives and grouts, the correct installation practices in accordance with British and European standards and surrounding legislation. Here are some suggestions for further reading and some useful links. Norcros Adhesives are always happy to provide specification support and advice at any stage of a project. Should you require any further information on any aspect we've spoken about in this seminar, please contact our specification advice line on 0870 609 2851 or email technical@norcros-adhesives.com.